We're at the start of a new project here. This is the battery box or the coffin for my 1998 Ford Ranger Electric, a factory Ford electric vehicle manufactured by Ford in 1998. I have one of a handful that still exist that was sold to the public. I have a red one, which was also kind of rare. But the original battery pack was 38 8-volt lead acid batteries. When I bought it 2 or 3 years ago, that battery pack had been removed and 26 12-volt lead acids had been installed in place of that. The overall vehicle weight was somewhere around 5,500 pounds with all that, and the total battery pack weight was somewhere like 2,500 pounds of lead in this box. This is the pile of 26 PowerSonic 100 amp hour 12 volt lead acid batteries that were in the truck. When I bought the truck a few years ago, it drove on the trailer. Everything ran. However, I could not get the vehicle to charge, and I could never actually get it to charge even after doing quite a bit of work on it. So I've made the determination that I had about a 4-mile range anyway with this lead acid battery pack. So I am now upgrading to a Renault Fluence zero emission Better Place battery pack. It is a 24 kilowatt hour battery pack. It is the same number of cells and form factor that is in the Nissan Leaf, at least the 2011-2012 Nissan Leafs. I'm going to be walking through the process to convert this battery pack over to lithium. The battery pack from the Better Place pack, the 24 kilowatt hour lithium battery, is already mounted in the bed. I have manufactured some aluminum rails that bolt between the original factory bed bolts, a steel frame that mounts the original battery pack from Better Place into the bed. That's been powder coated, and all the mechanical of that has been done. The battery pack has been bottom balanced and is mechanically mounted and assembled in the vehicle. I still need the original lead acid battery box, which is mounted underneath the vehicle between the frame rails. To get this battery box out that you see in front of us, it takes approximately 5 to 6 hours, and you have to lift the vehicle around 3 to 4 feet in the air to get this underneath. It's quite a pain, and I don't want to do it any more than I have to. So what I've decided to do is to run high voltage from my battery pack in the bed down into this box using 1 gauge wire, which is what the original battery pack used for its interconnects. Hook into the high voltage system and trick or spoof the original battery management battery protection system into thinking all the original 38 battery cells were there. You use a long stack resistor divider to basically determine to trick the battery system into thinking what it is. In this case, there will be 38 resistors in a series string and a wire tapping off each one at a particular point. That's what most of the orange harness is that you see before you. However, what I've chosen to do is do the absolute cleanest design or assembly that I can do, and that involves purchasing the original factory connectors, finding them, modifying nothing, and trying to get everything mounted in this box as best as possible and as clean as possible so that I have high reliability and never have to come back in here again. And I'm going to walk you guys through the process of finding those connectors and tracking everything down, making sure everything's right, doing the physical conversion, the cleanup, and all the wiring. It's for documentation purposes, so I can look back 10 years from now and see what I did. Okay, so what we're looking at is the front portion of the battery box. This is underneath the front of the vehicle. The control box at the very front has Velcro on the bottom of it, which will be used to mount to the bottom of the vehicle, the bottom of the battery box. This is the box that controls all battery-related functions and has a high pin count connector that connects to the vehicle on the left side. The harness that comes from the box to the battery has a series of connections on it that I'll go into in a moment. The mid portion of the battery pack has a fan in it right in front of and below the laptop. This is the rear portion of the battery box. What we're looking at is from the fan, which is about the midpoint, back to what ends up being right in front of the rear axle and the motor. The battery pack harness continues from the left side of the frame into view and has all the connection points to the original batteries. We have a harness right here that is in orange corrugated that runs from the rear power distribution box. The black box in the rear, right here, is the high voltage power distribution box for the vehicle. Battery plus and battery minus come in. There are two contactors inside, at least two contactors. That box handles all pre-charging and connects into the motor. The large connector that you see right there mounts in that position through that hole in the box right there and connects to the motor inverter. There is a 250 amp fuse that will be attached in this box. It is right back there. It's probably not going to be permanently mounted there. There are 4 thermal couples that were part of the original battery harness. Those have to be left connected, but they're not critical to the overall performance. You just need to have them hooked up, and the vehicle needs to know that they're there. This bottom matting, this battery pack had a heater modules in it that was actually disabled by the factory from what I've gathered. And I've removed the side Kapton style heaters. They were high voltage heaters, they ran off the battery. And this bottom mat is almost tarish. It's like a fiber tarred material. It does have wires going into it, so I assume it was also a heater pad. I'm going to be removing that and cleaning everything up. The edges of the battery box have a rubbery substance on them that will be removed. I think it was part of the original gasket material that was on the battery. When I got it, there was an additional piece of plastic wood that was built up an additional around an inch that was used to space off for the height of the batteries that I believe the previous owner had added and done a 12-volt conversion on. Behind this box, we see the lid to the battery box, and we also see that there has been some cutouts here, here, that were done to the original fiberglass. They appear to not have compromised the structural integrity of the battery, but it is not factory. What I've chosen to do is to pick up a couple of boxes from a local hardware store. And these are just standard 8-inch by 8-inch electrical boxes, plastic, 4-inch deep. And those will be Velcroed down to the bottom of the battery box. I've not worked out their final arrangements, where they're going. What one box will do is take high voltage from the battery above and connect it to the lower box, or the original high voltage power distribution box right here. The other box will be used to contain the resistor divider boards and all the connectors to the original battery harness. I am still investigating how to actually do that, and what I think I will do is I'm going to run harnesses along the original harness, connecting into all the original connectors, because I've found the mating halves to all these. And what it will allow me to do is make a high density connector on the side of the box that high voltage will come into, hook to the resistor divider, be fused, and around the edges will be the resistor divider boards mounted in the box. That way they're, inside of a sealed box, but outside of the elements. This is a sealed box, but it could get moisture in it, in a controlled location. There may be a third box somewhere in here, same size, that I will use to tap into the motor high power output. So if you see right here, I have the motor plus removed from the contactor in the box. What I would like to do with this battery is experiment with high speed charging. And this is the high voltage to the accessories that goes up front in this connector. I've removed it for development. Well, there's a common ground, a high voltage positive for the air conditioner, the heater, the DC to DC converter. There's a high voltage positive dedicated to the charger, and then I believe there's an interlock wire. The problem is that this harness only allows me to deliver 30 to 40 amps into the battery pack, and I would like to play with high power charging, and I believe I want to go up into the 250 amp range. Well, the only way to do that is to either hook directly to the battery, which I have access to, or through the high voltage distribution box. The problem I run into is that the vehicle does Coulomb counting and knows where the battery capacity is at the time. And if I do not run it through one of the battery shunts, the whole system will be confused in how it works. Well, there's only two shunts, and they're both contained within this box. One is for the charger, which works during charging, and the other one works when you're driving the car. That one is a high current shunt, and I'm going to be tapping into it to do the high current charging.